This morning, it landed. Qwen 3.8. 27 billion parameters, Apache licensed, weights on the hub, inside the window. They said next week, and they meant it. 9 days of 404s paid off. And having now read the entire model card, every table, every footnote, every configuration block, I can tell you the headline running around the internet today is the least interesting thing about this release. 3 things actually matter. First, this is not the architecture you think it is. Everyone will call it another 27B. But there's one line in the model overview, a single line describing how the layers are arranged, that quietly announces a different kind of machine. It's the reason this thing claims 250,000 tokens of context on hardware you can own. And I'm going to do the memory arithmetic on air, because the numbers are the story. Second, the benchmark table is the most audacious I have ever seen a lab publish. A 27 billion parameter open model, claiming wins over the strongest closed model on the market. And here's the twist. Evaluated inside that rival's own tooling. The footnotes on that table are a masterclass in both transparency and framing, sometimes in the same sentence. And we're going to run our 5-question decoder on them. And third, read to the very bottom of the card, the citation block, and you find one word that reframes the entire launch. What shipped today and what conspicuously didn't tells you exactly who's paying for this generosity. The invoice is printed on the card itself. Plan. What landed and the receipts of the stakeout, the architecture line and what it means, the memory arithmetic, the thinking controls, the benchmark forensics, who pays, what this means for the machine under your desk, and the honest limits, which today start with how this card reached me. Standards note, and it matters more than usual. My environment cannot reach the model hub, so the card was pulled from the hub and supplied to me in full this morning. Everything I quote is verbatim from it. Everything I compute I'll show, and I'll flag the one thing I couldn't check. The weights themselves, nobody's run them here. Let's go. What landed, and the stakeout receipts. The drop. Qwen 3.8 27B in an FP8 quantized repository. License field reading Apache 2.0. The real license, not a community terms lookalike. And the model type tag surprised me. Image text to text. This is not a text model. It's a native vision language model. The card says images and video, and not clip-length video either. Their phrase is hour-scale videos. A 27B you can own that watches an hour of footage. Hold that. The architecture section explains how that's even affordable. 2 details from my own morning probes that tell you how launches work now. The GitHub organization repository is still not found. Right now, as I record. The weights went to the hub first. The code forge is lagging behind its own launch. Hub first is the new front door. And second, the fine-tuning toolkit everyone uses already lists this model in its README. I pulled that file this morning from my side and found the name sitting there. The ecosystem had rails laid before the train arrived, which brings us to a tag on the card that explains the speed. The architecture identifier reads Qwen 3.5. The card says it plainly. Built on the architectural foundation of the previous generation. Same skeleton, new training. Which means every serving engine that ran the last generation runs this one on day 0, with 0 new code. That's why next week was a promise they could keep. The hard compatibility work shipped months ago, disguised as the previous release. There's a lesson in that alone. In this era, the release is the weights. The architecture ships early, wearing the old model's name. The line that changes the machine. Now the model overview, and the single line I promised. Under hidden layout, the card reads verbatim. 16 times, 3 times, gated delta net, then feed forward, then 1 time, gated attention, then feed forward. Decode that. The model is 64 layers. They're arranged in 16 identical blocks of 4, and in each block, 3 of the 4 layers are not attention at all. There's something called gated delta net, a linear attention mechanism. Only every 4th layer is real, classic, quadratic attention. 48 of the 64 layers have abandoned the mechanism that gave transformers their name. Here's the difference in plain terms, and it's the best 90 seconds of theory you'll get this week. Classic attention rereads the entire transcript for every new word, every token it generates. It looks back at everything, which is why it's brilliant and why it's expensive. The memory of that lookback, the KV cache, grows with every token and never shrinks. A long conversation pays rent on every word it has ever said, forever. A linear attention layer keeps a running summary instead. A fixed size state, think of a notebook that never gets thicker, updated as each token passes. It doesn't reread the transcript, it consults the notebook. The price is fidelity. A summary is not a transcript, and pure linear attention models historically forget precisely the details you needed. The bet this architecture makes is the ratio. 3 notebook layers for every 1 full reread layer. The full attention layers provide the perfect recall. The delta net layers carry the bulk of the computation at a flat rate. Recall where it counts. economy everywhere else. And before trusting any of it, I did what this channel does. Checked whether the card's numbers multiply out to 27 billion token embeddings, roughly 248,000 vocabulary times a hidden size of 5,120, about 1.3 billion. And the card lists the output layer separately, so double it. The feed-forward networks, gated, 3 matrices each, times 64 layers. Call it 17 billion, the bulk of the model. The 16 attention layers, slim by design, around a billion. The 48 delta net layers, about 4 more. Sum it, add the glue, and you land at 27 billion. On the nose. The card is internally consistent. Arithmetic first, adjectives later. The Memory Arithmetic. Why 250,000 tokens fits on your desk. Now the payoff of that layout, and this is the section to send to your friend with the graphics card. Context length. From the card, 262,144 tokens, natively, 250,000, extensible up to 1 million. On a 27B, how is that not a memory catastrophe? Count with me. The KV cache, the growing transcript memory, only exists for attention layers. This model has 16 of them, not 64, and those 16 use aggressive grouped query attention. The card says just 4 KV heads at 256 dimensions. So per token, 16 layers times 2 for keys and values, times 4 heads times 256 numbers. 32,768 values per token. At 1 byte each in FP8, call it 32 kilobytes per token of context. Fill the entire 250,000 window, 32 kilobytes times 262,000, about 8.5 gigabytes, for the full native context. Now build the counterfactual, the same model with classic attention in all 64 layers. 4 times the cache, 34 gigabytes for the same window, before you've loaded a single weight. That's the difference between fits beside the model on a big consumer card and requires a server. The 48 notebook layers pay no rent at all. Their state is fixed size, the same footprint at token 10 and token 200,000. That's the law of this release, and it's one to keep. Classic attention rents memory by the token forever. A recurrent state owns a fixed apartment. This architecture moved 3/4 of the building out of rentals. And that's why hour-scale video and 250,000 contexts stop being absurd claims at this size. The weights themselves, 27 billion parameters at 1 byte in this FP8 repository, on the order of 2728 gigabytes, and I'll label that an estimate since the file listing wasn't in front of me. That's the 32 gigabyte class as shipped, and the community quantizers, already listing it, will bring the 4-bit builds to the 16 and 24 gigabyte class within days. Every parameter active on every token. A classic, monolithic design, no experts, no streaming, no drive dependency. In the 2 races language of this channel, this model runs the race where the whole team fits in the building. Your drive is irrelevant. Your VRAM is the whole game. One more piece of craft. The million token extension isn't hand-waved. The card publishes the exact configuration overrides. The scaling method spelled YARN. The factor, the rope parameters, per serving engine, copy-paste ready. And then, unprompted, the honesty note. The engines implement static scaling, which can hurt short context quality. So, their words, modify the configuration only when processing long contexts is required. A vendor telling you when not to use their headline number. Noted and credited. A model with an effort dial. The agent era controls. The card's controls read like they were designed by people who run agents all day, and 3 deserve air. Thinking is on by default, with a dial. Reasoning effort, 3 positions, the highest as default. 2 full sampling personalities, 1 for thinking mode, 1 for direct answers, different temperatures, different penalties, printed side by side. Then the sentence that tells you these people operate fleets. On the temptation to turn effort down for speed, the card warns, nearly verbatim, lower reasoning effort does not always reduce overall task completion time. It can produce faster turns but more failures and repeated retries, increasing total latency and token consumption. That is a measured insight. Anyone who has watched an agent sprint confidently into a wall 5 times knows it's true, and I've never seen it printed on a model card before. Second, preserve thinking on by default. The model retains its reasoning blocks across the whole conversation history, not just the last turn. The stated reasons, decision consistency for agents, and, the tell, better KV cache utilization. They're managing the memory economics of their own thoughts. And third, the budgets. Recommended maximum for reasoning, 262,000 tokens. For the final answer, 131,000. Read those again. The thinking allowance equals most models' entire context window. This is a machine specs to disappear for an hour and come back with the work. which is exactly the shape of the week's whole story, from the fleet dashboards to the office benchmarks this card reports. The benchmark table. Forensics with the decoder. Now the audacious part. The card's table lines this 27B up against its own previous generation, its bigger hosted sibling, the fresh open 30B from the social giant, and the strongest closed model on the market. Let's run our 5 questions because this table rewards them. The claims, as printed, on the agentic software benchmark Suffix Pro, 61.7 against the closed flagship's 53.4, on long horizon office work, 70.7 against 68.2, on instruction following, 79.5 against 62.5, on computer use, operating a desktop, 84.3 against 72.7, a model you can download claiming the top spot against the model everyone rents, and against the social giant's brand new Open 30B, wins on every row where both have numbers. The loss is also printed, credit where due. Terminal-based coding, the closed model holds it, 78 to 73. Deep scientific reasoning, closed model. The hardest exam benchmark, 40 to 30.8, a clear printed defeat. And on several multimodal rows, the card lets its own hosted sibling beat the open release. A table that hands its rivals bolded, wins earns more trust than one that doesn't. Now the footnotes, where the truth lives. Question 1. Which race was timed? Mixed. Some rows are their own in-house benchmarks, named as such. Office work, their software suite. Self-refereed, treat accordingly. Question 2. Whose stopwatch? Here's the astonishing detail. Multiple rows state, verbatim, evaluated with the Claude Code harness. They benchmarked their model inside the rival's own agent tooling, walked into the champion's gym, and posted numbers on the champion's equipment. As a credibility move, it's brilliant. As a chess move, it's better, because it also says our weights run great in your favorite harness. Question 3. Same conditions for everyone? Not quite, and they say so. On the headline row, the closed model's score is the officially reported one, while everyone else was rerun on a version of the benchmark where, their words, problematic tasks were corrected. Different track for the incumbent. Stamp it, not apples to apples. Question 4. Anti-cheating? Genuinely good. On the repository benchmark, they disabled the shell commands agents use to peek at answers. Their list, verbatim, pip download, pip install, and git clone. That footnote should be standard everywhere. Question 5. The judge. One benchmark is scored by a rival lab's previous generation model, named right there in the footnote. An aging judge for a frontier exam. My verdict, honestly tiered, the pattern is credible. The generational deltas are enormous. Their own previous 27B scored 13 on one agentic suite. This scores 42. You don't footnote your way to a 3x. The exact placements versus the closed flagship are reported claims with mixed conditions, and they stay labeled that way on this channel until independent numbers exist. But the meta-story stands regardless of a point here or there. A lab now considers it reasonable to print a 27B open model in the same table as the best closed model on Earth. 5 months ago, that table would have been a joke. Today, it's a press release. The other new arrival, a head-to-head the card already started. One comparison in that table deserves its own minute because it's the matchup of the month. 2 days ago, the social media giant shipped its first open weights in 16 months, a 30B, Apache licensed, built for the 24GB class. Today's drop is a 27B, Apache licensed, aimed at the same desks. 2 fresh open models, same weight class, same week, from the 2 most watched labs in OpenAI. That's not a coincidence. That's a market forming around a specific size. The biggest model that fits on hardware a person actually owns. And this card doesn't pretend the rival isn't there. The 30B sits right in the table and on every row where both models have numbers. Terminal coding, instruction following, scientific reasoning, chart analysis, document intelligence. The card claims the win. Some rows by a little, the document row by 15 points. Honest reading, those are the home team's numbers, the rival's cells are sparse, half the rows show no result for it at all, and a vendor's table is the last place a rivalry gets settled. But the shape of the contest is now set, and it's wonderful for everyone watching. The desk class crown is suddenly contested in the open under Apache by labs that ship. The source level face-off, both cards, both configs, both licenses, side by side, is exactly the kind of video this channel exists for, and it's now officially in the queue. Who pays? The invoice is printed on the card. Standing rule, find the invoice. This one took no digging. The card, verbatim. The model will be available as a hosted version with more production features. For example, 1 million context length by default, official built-in tools. Service, coming soon. So, the open weights give you a 250,000 of context, Apache, forever yours. The hosted product gives you the million by default, plus tools, plus 0 infrastructure. The context length is the paywall. You get a generous house, they sell the mansion as a service. And then the citation block, the twist I flagged. The suggested citation's title is not this model. It reads, verbatim, Qwen 3.8 Max, a new bar for coding and co-work. Max, the flagship. The blog is about the big one, and the big one's weights are not in today's drop. What landed is the 27B, the ambassador, the deployable sibling, the one that fits on your desk and carries the family name into every harness and quantizer within a week. The promise? Open weights next week was kept precisely by the model that makes the ecosystem love you while the crown stays hosted. That's not a criticism. It's the clearest statement of the modern open weights business I've seen. Release the model that spreads, sell the model that peaks. What to do this week? 3 moves. Before the caveats, the practical layer, 3 ways. If you own the hardware, know your class before you download. The FP8 repository as shipped is the 32 GB class. The 4-bit community builds, and the major quantizer already lists the model. We'll bring the 24 and 16 GB class into play within days. One provenance rule from this channel, always. In the first rush, take quantizations only from sources you already trust, and check the upload actually derives from this repository. Launch weeks are when lookalike uploads thrive. If you build agents, the experiment worth running is the effort dial, and the card itself tells you how to measure it. Run a real multi-step task at the highest effort, then at medium, and time the whole task, not the turns, because their own warning says the cheap setting can lose on retries. If that warning replicates on your workload, it changes how everyone should budget reasoning, and your comment with the numbers is worth more than this video. And if you're the skeptic, good, be that. Here's what's falsifiable this week. Independent runs of the headline coding benchmark, outside the vendor's recorrected version. Real tokens per second reports at real context lengths, which will test my cache arithmetic against the world. Whether the organization's code repository materializes, and with what. And the max question, whether the flagship's weights ever follow the ambassador out the door. Every one of those has an answer within days, and this channel will be checking each morning. The stakeout ends, the watch list never does. Honest limits. 5, and today the first one is unusual. 1. The card came to me. I didn't fetch it. My environment can't reach the model hub, so the card was pulled from the hub and supplied in full this morning. I cross-checked it every way I can from here. The parameter arithmetic closes. The architecture tag matches the previous generation exactly as claimed, and the fine-tuning toolkit's README independently lists the model. But that's corroboration, not a checksum, and I'm telling you so. 2. Every benchmark number is theirs. Vendor table, in-house suites included, mixed evaluation conditions per their own footnotes. Reported, not reproduced. Independent runs will exist within days. Recalibrate then. 3. Nobody here ran the model. Speeds, real memory use. The feel of it, unknown. The memory figures I computed are physics from the published shape, not measurements. 4. The weight sizes are estimated from parameter count and precision. The file listing wasn't in front of me. Expect the real shards to land within a gigabyte or 2 of the estimate. 5. This is hours old. The organization's code repository isn't even live yet as I record. Sizes, siblings, the max situation, the hosted timeline, all of it can change by tonight. This video is a photograph of a launch in motion. Step back because 2 stories ended this morning. The small one is ours. 9 days of automated 404s, 1 false flicker, and a landing inside the promised window. A lab said, next week, and delivered. In a year of vaporware demos and waitlists pretending to be releases, promise keeping is becoming a competitive feature, and worth rewarding with exactly this kind of attention. The big one is the architecture. 48 of 64 layers walked away from classic attention, and the memory bill collapsed accordingly. 250,000 context in single-digit gigabytes of cache. All year, this channel has covered the context problem from the software side. Compaction, memory files, retrieval, the context rot fixes, trending right now. This is the same war fought from below. Change the physics so the transcript stops being the enemy. The software layer and the architecture layer are converging on the same conclusion from opposite directions. The context window, as we knew it, was a design mistake we're all busy correcting. And the quiet law underneath the whole release, the gap between open and closed is no longer measured in miracles. It's measured in months and gigabytes. A 27B you can own now sits in the same benchmark table as the best rented model on Earth, printed by people confident enough to show their losses. So here's my question, and I'll pin it below. This machine reads images, watches hour-scale video, holds 250,000 tokens, and fits on a card you can buy. What is the first real task you'd trust it with? And on exactly what hardware? Name the GPU, the quantization you're eyeing, and the job. And when the community builds land and you have actual numbers, tokens per second, context you really loaded, bring them back to this comment section because the first week of real-world reports is worth more than every table and every card. Every link, the model page, the previous generation's architecture it inherits, the serving engine recipes, the quantizer already listing it, and our full breakdowns of the context war this connects to is in the description. Read the hidden layout line yourself. It's one sentence, and it's the future. That's the standard here. The whole card actually read, the claims tiered, the arithmetic shown, the promise keeping credited, and the stakeout finally over. If you'd rather own your tools than rent them, subscribe. That's what we do every single day. I'll see you in the next one.